Hello friends, in this video we will solve problem based on 3D transformation. So here is the first problem. Write necessary steps and transformation matrix for rotating a point in a 3D space about a given 3D line. So in this problem we have to rotate a point which is in a 3D space, and we have to rotate this point about a given 3D line. So until now we have seen for rotating a point or an object with respect to any of the coordinate axes such as x, y and z. But in this case we have to rotate a point or object about a 3D line, that is arbitrary line which does not coincides with any of the axes. So in that case we have to set up a series of or composite transformation which will include translation transformations and rotation transformation, because in this problem we have to perform rotations. So now we will draw the figure. So here is a solution. This is x-axis, y and this is z1. This is the 3D line PQ whose coordinate is x1, y1, z1, and the coordinate of Q is x2, y2 and z2. This is a given 3D line which I can say it as arbitrary axis which is having x, y and z coordinates, and this is that point. This is that point which is to be rotated. This is a 3D point whose coordinate is x, y and z, which is to be rotated about this 3D line. Okay, so we already said for performing this transformation matrix or for performing, we will require composite transformation which will include translations and rotations. So the first transformations here we will do is translation, because unless and until the line is not brought to the origin we can't perform rotation matrices or rotation transformations. So here we will perform translation transformation firstly. So before starting, for I will write A for x coordinates, that is it will be x2 minus x1, and I will name for y B, that it will be y2 minus y1, and for C it will be z2 minus z2. So first transformation is translations. Translation. So we will translate any of the point, that is P or Q. So we will translate point P to origin. So we know the standard translation matrix as T equal to 1 0 0 0 0 1 0 0 0 0 1 0 Tx, Ty, Tz and 1. So this is standard translation matrices for 3D. For that we will require the value of Tx, Ty and Tz. So here, so for bringing this point to origin, so I have to travel in x1 direction, that is x1 units along x direction, y1 units along y direction and z1 unit along z direction. So since we are moving from right to left, so sign convention will be negative. So it will be, so Tx will be minus x1, Ty will be minus y1 and Tz will be minus z1. So T will become 1 0 0 0 0 1 0 0 0, 0, 1, 0. Tx is minus x1, ty is minus y1, tz is minus 1. So this is the matrices which we received after performing translation. So now initially the figure was in this way. So after performing translation transformation, the figure will be transformed into this figure, which I will draw now. This is x, y and z. So after performing translations, the line is come somewhere here, PQ. And the point will come somewhere here. So this is a figure after performing translation. So now the 3D line is brought or shifted to the origin. Now point is come somewhere here. So now the next transformation, here we will do rotation because it will involve composite transformation. So for that I have to rotate this line in anti-clockwise rotations, means in anti-clockwise rotation, so that the line, that is line segment, is brought onto this exact plane. So we have to bring the line segment in exact plane. For that we will rotate this line anti-clockwise direction. So next transformation here is rotations. That is rotation. Rotate line PQ theta x degree, we have to rotate by theta x degree anti-clockwise about x axis. Your rotation is anti-clockwise direction and we have to rotate it by theta x degree. So the standard matrices for rotation about x axis is given as 1, 0, 0, 0, 0 cos theta, sin theta, 0, 0 minus sin theta, cos theta, 0, 0, 0, 0, 1. So this is the standard matrices for rotation transformation. So now after performing rotation transformation, the figure will be transformed. So I will use this figure only. So we were rotating it by theta x degree, that is anti-clockwise. So now it will come, the line segment will be in this plane, that is in exact plane, because of that only we have done rotation, so that about theta x degree, so that we will bring that line segment on exact plane. So it will come somewhere here, that is by theta x degree. So now we successfully rotated line PQ by theta x degree anti-clockwise about x axis. So now if we will throw a light, if we will focus a rays of light in this x direction, that is along x direction, this light, so the shadow will be seen on YZ plane. We are just focusing the source of light in x direction and the figure or the shadow will be seen on YZ plane. So this will be shadow. I will name it as Q dash, and now I will drop this Q dash on Z axis, and now I will draw a perpendicular on Z axis, and I will join P and Q. I will join PQ and P and Q dash. So I will name this point as M, and this angle is theta x, and I will name PQ dash as U, MP as C, and Q dash M as B. I am just naming. So now we'll refer the figure. From this, it is right angle triangle QMP U, which is equal to B square plus C square. This is hypotenuse side, and we are adding, which is U square, U, which is equal to under root B square plus C square. So now from the figure, cos theta x, which is equal to, this is theta x, so adjacent side is PM, so which is C, and hypotenuse is U. So we got relation for cos theta x, that is C by U, and sin theta x, so opposite side, which is B, and hypotenuse is U. So we are using this triangle QMP so that I can get the relations for theta, cos theta x and sin theta x. So now we will use these relations. So now we will replace the value of cos theta as C by U and value of sin theta as B by U. So 1, 0, 0, 0. The value of cos theta is C by U, value of sin theta is B by U. This is 0, 0 minus B by U. This is C by U, 0, 0, 0, 1, 0, 1. So this is matrices which I got after performing rotation about x-axis. So after performing rotation, the line is been transformed as PQ dash. Initially it was here. After performing rotation by theta x degree anti-clockwise, the line has come here. So now we will rotate this line PQ by clockwise direction, so that it will get coincided on z axis, and once it is coincided with z axis, we can perform the standard transformation matrix, which the point is also rotating. Initially point was here and now point is come here. So once we will perform rotation by theta y degree about y axis, so it will get coincided on this z axis, and once it is coincided on z axis, we can easily perform rotation about z axis, which we want in this problem. So now next step is rotation about y axis. So now third is rotation so rotate line PQ at y axis by theta y clockwise. So we are moving clockwise rotation. So now we will write the standard matrices for rotation about y axis, which is r equal to about y cos minus theta y 0 sin minus theta y 0 0 1 0 0 minus sin minus theta y 0 cos minus theta y 0 0 0 0 1. So this is the standard matrices for rotation about y axis by clockwise direction. So now the initial figure was this one. So after performing rotation about y axis clockwise direction, the figure will become, I am drawing in next page so it will get cleared. So now we will draw the figure after performing rotation about y axis. So now this got coincided with this z coordinate. This is x, this is y, and this is z. So this is that q dash and this is p, and we will draw the shadow line which we got by focusing the source of light along x direction, which I would named as q. So I will draw this line on that axis. So the point will come some here after performing rotation about y axis. So originally q was here, this line before rotation about x axis, y axis. So I will join this line, all these points. This is the perpendicular, and this line is coincided with z axis on z axis by theta y degree. So when we were performing rotation about x axis, at that time the active plane was exact plane, so the coordinates of x remains unchanged and the y coordinate value becomes 0, because while performing rotation about x axis we were focusing on exact plane, so the coordinates value of x remains unchanged and x values remains unchanged and y coordinate value became 0. So now because of that case the value of this c has been replaced by the value of u. So now I will name it as u, because initially it was here and now it is replaced by c is replaced by u. So I will name q and q dash as a and p and q as v. So now v which is equal to a square plus u square, v that is hypotenuse which is equal to a square plus u square. So we know that u square as b square plus c square. So I will write as b square plus c square. So we are doing this because we want to get relation for cos thetas and sin thetas. So the cos theta y will be, since we are performing here clockwise rotation, so this will be minus theta y, so it will be u by v. So since cos is don't care condition, the value will be, it will not affect cos, so I can write it as cos theta u upon cos theta y as u by v. In the case of sin theta, again we are performing clockwise rotation by y around y, sin theta, which is opposite, that is opposite is a and hypotenuse v. Since in the case of sine we have to consider the sign of minus, so it will become minus a by v. So these two relations we will use in the matrices. So the matrices will become Ry, which is equal to u by v 0 minus a by v 0 0 1 0 0 a by v 0 u by v 0 0 0 0 1. We are requiring the values of cos theta and sin theta, that's why we are using the relations, so that we can replace that theta values with the relations u and v. So now after performing these transformations, the point has been transformed in this way. So now we can successfully rotate this point about this z axis. So now we will directly use the standard matrices for rotation about z axis. So next transformation we will do here. That is, this is fourth one, which is rotation. This is the required rotations. About z axis by theta degree, because this is only the thing which we required, which we attained for rotating a point about a given 3D line. So we successfully rotated by performing the rotation about z axis by theta degree. So Rz will be cos theta sin theta 0 0 minus sin theta cos theta 0 0 0 0 1 0 0 0 0 1. So this is the matrices for rotation about z axis. So we successfully rotated a 3D point about a given 3D line. So for performing that thing, we done series of or composite transformation. So for that, for generating rotation about z axis, we have done series of transformation. So for that, we have to place that 3D line back to its original position. For that, we have to do series of back translation. So we have done rotation about y axis, rotation about x axis, and translations. Because unless we haven't done that rotations, composite rotations, we couldn't do the rotation of 3D point about a 3D given line. So for that we have done series of composite transformations. So now fifth transformation we will do is back translation, back rotation about y axis by theta y degree. So since initially we rotated at y axis by theta y degree clockwise direction, in this back rotation we will do anti-clockwise. So the standard matrices, or just do inverse of which we have done before. So I will write as Ry inverse. It will be u by v 0, a by v 0, 0 1 0 0 minus a by v 0, u by v 0, 0 0 0 1. So this is the matrices for back rotation. Then we have done rotation about x axis by theta s degree anti-clockwise. So now we will do back rotation about x-axis by theta x degree. In that case we have done anti-clockwise rotation. Here we will do clockwise rotation, or just write Rx inverse, do inverse which we originally did before. So Rx inverse will be 1 0 0 0 0 C by U minus B by U 0 0 B by U C by U 0 0 0 0 1. So this is the matrices for back rotation. Then we have to do back translations. 7 is back translation. Point P, we have to do back translation point P. So just do inverse of which we done earlier. So that will be 1 0 0 0 0 1 0 0 0 0 1 0. This will be positive x1 y1 z1 1. So now problem based on 3D transformation. So now this is matrices for back translation point P, that is we are placing back to its original position. So now in this problem we have done series of composite transformation. So for that case we have to write, or we have to find resultant transformation, because in this problem we have to do necessary transformation or necessary steps, and we have to derive transformation matrix, that is resultant transformations. So resultant transformation TR. So first we have done translation, then we have done rotation about x axis, then we have done rotation about y axis, then rotation about z axis, then rotation y inverse, that is opposite of ry, then we have done rotation about x axis, and lastly we have done translation, that is back translation. So now we will multiply all the transformations so that I will get TR. So the final TR, so after performing or after solving all the matrices, we will get the final matrices. So the final matrices will be the value for TR. So we successfully rotated a 3D point about a given 3D line.